Today's tutorial, I'm going to show you how to solve first order differential equation that's homogeneous type in a very simple way. For first order differential equation, we have two types. We have homogeneous and we have the non-homogeneous. Homogeneous has equation equal to 0. Equation equal to 0. And non-homogeneous, it has equation equal to a function. It could be a function of x. And on this equation, we are going to solve for y, and y is the dependent variable. We say dependent variable because it's the unknown variable. Dependent is equal to y, which is the same as the unknown. Okay, so for this type of equation, to make a very simple way, we follow two steps or two stages. For step 1, transform this equation to a standard form. So we need to transform the equation to standard form. And we need to rearrange the equation. Rearrange. Alright, so to solve this equation, step 1, the equation gives us x dy over the x plus x squared y equal to 0. We see that we have to make this standard form, and making a standard form, the coefficient of dy over the x is supposed to be 1. And looking here, the coefficient of dy dx is x. It's x. So we need to make it 1. For making it 1, we have to divide through the equation by x. X dy over the x plus x squared y equal to 0. When we divide through by x, this is how equation looks. X 0 over x is still 0, so we just forget it, do go to 0, so equal to 0. X over x, it goes to itself 1, so making it cancel itself. But I don't want to use the word cancel, but you see, for making it to understand, let's say cancel. So when it cancels, it gives us 1 and give us dy over the x plus the x goes to x squared 1. Yeah, so it gives us xy equal to 0. We need to step 2, we need to rearrange dy over the x is equal to, we bring this one to the right side, making it negative minus xy. Let's continue from this one. Dy over the x equal to minus xy. Okay, we have dy over the x and we have minus xy. See, dy over the x, we have to make it a variable of y. So we need to multiply through by the x and we have to divide through by y. So when you do that, when you multiply and divide through, you get equation to be dy over, this one will divide this side to make it y equal to minus x, this one multiply this side making it dx. At this point we need to integrate. So when you integrate dy over y equal to, we have minus here, so minus integral of x dx. It's very simple here. When you integrate dy over y, is the same as 1 over y dy equal to minus x dx. And 1 over y, 1 over any variable, give us ln of what? The variable. So 1 over y give us ln y. And the right side, when you integrate x, see, you get your minus here. When you integrate x, is x to the power of x is 1. So 1 plus 1 all over the exponent of the word x. And the exponent here is 1 plus 1 now. So 1 plus 1. Then bring your constant c. Ln of y is equal to minus x 1 plus 1 give us 2 all over 2 plus z. So this is the final answer for when you solve for x dy over the x plus x squared equals to 0. This type of equation is called homogeneous because it equals to 0. Thank you. Let's solve another equation here. For this kind of equation, we've just changed the variables. It's the same step. We've just changed the variable. Instead of x, we made it theta. So step 1 says we should make it standard form, and 1 over theta dy over the theta. So it means the theta here is the independent variable and y is the dependent variable. Theta keep y equal to 0. We have 1 over theta, and making a standard form, the coefficient of dy over the theta is supposed to be 1. For now, the coefficient is 1 over theta, which is not appropriate, so we have to make it 1. And making it 1, we have to multiply through the equation by theta. So 1 over theta, equal to 1 over theta dy the theta plus theta cube y equal to 0. So we are multiplying through by theta. So theta, we are multiplying through theta. Yeah, I said you don't need to multiply. When you multiply this by this, it gives us theta over theta dy over the theta plus theta to the power 4. You multiply this by this, it's already power to 3. So when you multiply 1 by this, give a theta 4. So y equal to 0. Theta over theta give us 1. So we've reached the standard form, which is dy the theta plus theta for y equal to 0. Very simple. And this stage, we call it step 2 or stage 2. We need to rearrange dy over the theta equal to, we bring this one to the right side, make it negative theta to the power 4y. At this point, we need to multiply and divide. Dy over the theta, we need to multiply the theta through and we have to divide through by y, so that we get dy over y equal to, sorry, I didn't bring the equal sign, equal to minus theta to the power 4. Then we multiply this one here, it means we've gotten dy over y, so we need to integrate to get our y. We integrate dy over y equal to, we integrate theta to the power 4 the theta. And here we have minus sign, you have to still bring it back. If you remove it, you are just going a bullshit. Sorry. Dy over y. See here, we can still write it as 1 over y dy equal to minus theta to the power 4 the theta, and 1 over y is ln of y, and when you integrate theta to the power 4 is theta 4 plus 1. You maintain the power and you add 1, then you divide through by the current exponent, which is 4 plus 1. Don't forget to bring your minus sign plus your constant. Okay, let's continue from this side. So ln y equal to minus theta 4 plus 1. See here, 4 plus 1 is 5. So theta to the power 5 all over 5 plus your constant. So this is the final answer for 1 over theta dy over the theta plus theta to the power 3, or theta cube y is equal to 0. And this is the final answer. Thank you for watching.